So our goals for today in section 1.4 are to solve absolute value equations and inequalities. So let's start with the definition of absolute value. The absolute value of a number is the distance between the number and 0 on a number line. So when we look at the absolute value of a number that is greater than 0, for example, the absolute value of 5, we get 5. So the absolute value of x equals x if x starts out positive. If x starts out as negative, then the absolute value of a negative is still positive. So the absolute value of that initial negative number is positive 7, which is the opposite of that inside number. What is, or what are, the values of x if the absolute value of x equals 2? So we're saying what numbers have a distance of 2 from 0 on the number line. 2 and negative 2. And you probably know already the absolute value of 2 would be 2, and the absolute value of negative 2 would be 2. What is, or what are the values of x if the absolute value of x equals 7? 7 and negative 7. And third, what is, or what are the values of x if the absolute value of x equals negative 5? So this is no answer, or the null set. There are no numbers whose distance from 0 on the number line is negative. So there are no solutions. Empty set to that last one. Steps for solving an absolute value equation. Step 1, we're going to get the absolute value alone on one side of the equation. Then we're going to rewrite without bars and then we're going to rewrite without bars. And the difference between these two is we're going to rewrite without bars, set equal, to positive, and we're going to rewrite without bars, set equal to the negative. So we're going to negate the other side of that equation. We're going to solve both equations and then we're going to check. Checking this here is very important, so make sure you are checking. Let's try these steps out on a few problems. Question number 1. Get the absolute value bars alone on one side of the equation. So they are already alone on one side. Then we're going to rewrite without bars, set equal to the positive. So that's 2x minus 3 equals 17. And rewrite without bars equal to the negative. So you're going to take whatever is on this side of the equation and keep it and negate it for your two equations. We're going to solve both equations. Adding 3, dividing by 2, adding 3, dividing by 2, absolute value of 2x minus 3 equals 17. We're going to do the absolute value of 2 times 10 minus 3 equals 17. We're going to check that. That's the absolute value of 20 minus 3 equals 17, and that indeed is true. 17 equals 17. For the other check, I'll do that down here. We have the absolute value of 2 times negative 7 minus 3 equals 17. So that is the absolute value of negative 14 minus 3. So it's the absolute value of negative 17, which we know its distance from 0 is 17, and you have a match, so that it checks. Make sure you always go back to the original when you are checking. Need some room over here. You can rewind the video if you need to go back and see that check, or pause the video at any time. All right, back through the steps. New problem, number 2. Get the absolute value bars alone on one side. So I want this to be alone. I need to subtract 5. Okay, now we're going to split and rewrite without bars set equal to what we have. And rewrite without bars equal to the negation of this side. So negation of 2x, negation of negative 5 is positive side. So you end up doing negative of 2x minus 5. All right, we're going to solve both of these. Let's see. I'm going to do this a different way. I'm going to bring the x over. So I have 3 equals x minus 5, and add the 5 over. So I have x equals 8. And same thing over here. Bring that x over. That makes a bit of a mess, but that's okay. Yeah, I'm going to change my mind. Sorry about that, guys. Oh, you know what? I shouldn't change my mind. Okay. 3 equals negative 3x plus 5. Subtract the 5. We get negative 2 equals negative 3x. Divide by negative 3. I think it would be an ugly answer any way you did it. Okay, so we have to do our checks now. And we're going to go back to the original. Absolute value of x plus 3 plus 5 equals 2 times x. So if we start and put 8 in there, the absolute value of 8 plus 3 plus 5 equals 2 times 8, or absolute value of 11. And the absolute value of 11 is 11. So we have a nice check there. And for 2/3, let's take our original again. Absolute value of x plus 3 plus 5 equals 2 times x. And put our 2/3 in. I'm going to switch to thirds for 3. And 2 times 2/3. Just running out of room. Let's see, extend my page a bit. There we go. So I have the absolute value of 11/3 plus, I'm going to change my 5 to thirds also, 15/3. That's going to be 26/3 equals, and on this side we get 4/3. So we have a situation where it does not check. And when it does not check, we need to reject our answer. And make sure you check over your math. Make sure you didn't make any silly mistakes. Sometimes that happens, but for the most part, there will be problems that do not check, and you need to remember to reject those answers. Okay, number 3. We need to get the absolute value bars alone. So we're going to subtract 4. two sides, write it without the bars, equal to the positive of that side, and write it without bars, equal to the negative of that whole side. This one's a little easier to solve. And of course we have to check. So the original 2, absolute value of y plus 3 plus 4 equals 34. We'll check that. And we will check 2, absolute value of negative 18 plus 3 plus 4 equals 34. Okay. So the absolute value becomes 15. That's 2 times 15, which is 30 plus 4, and I think you can see that one is working out nicely. Here we have 2 times the absolute value of negative, whoops, let me redo that. 2 times the absolute value of negative 15. Just trying to see if the two sides are equal. 2, the absolute value of negative 15 is 15. And sure enough, we've got a match where they both check. Okay, so let's go on. If instead of equations we have inequalities, then there is a little bit of a difference. So this says, what are some numbers in the solution set of the absolute value of x, so the distance away from 0 is less than or equal to 3? Well, if it was equal to 3, we know we would have negative 3 and 3. So where is the distance less than 3 from 0? Well, all the way out to negative 3 and all the way out to 3. So any number on the number line between negative 3 and 3 is a solution set for that. So we would have negative 3 is less than or equal to x is less than or equal to 3. Which also means you could write this as x is less than or equal to 3 and x is greater than or equal to negative 3. And is the conjunctive case. So you can write them separately or as a compound inequality. So if this little part here is just a little a matter of reading carefully, because if the book asks you for just the integers between negative 3 and 3, or to give solutions that are just integers, then I actually just have to list the integers from negative 3 to 3. Whereas this type of a solution contains all the decimals as well and every little fraction between there. So let's switch that up now. What are some numbers in the solution set where the distance away from 0 is greater than 3, greater than or equal to 3? So negative 3 and 3 again. So what numbers would be farther than 3 away from 0? 4 and 5, of course. And higher, so everything from 3 higher, and negative 4 and negative 5 are farther away from 0, so everything from negative 3 and less. So that solution set looks like our x's are less than or equal to negative 3, or our x's are greater than or equal to 3. And you can only write that one separately. And again, if the domain were restricted to just integers, if they just want integers, then you'd have to list them out, and like so. So when we have a less than something, the absolute value is less than, we're going to get a solution set that is between two numbers. So we're going to get negative k is less than or equal to x is less than or equal to k, whatever that number is. And when we have a greater than, then our solution set is that our x's are less than or equal to negative k. Did I include, oh, I didn't include equal to, let me get rid of that. Our x's are less than negative k, or our x's are greater than k. So that's the difference in those. So what we learn here is we can remember that if we have a less than symbol, then we know it's going to be an and inequality, or this case here. If we have a greater than symbol with our absolute value on the left, then we know we're going to have an or a disjunctive situation, and we're going to have this situation here. So try and remember less than and greater, and it will help you get some of these done, or at least recognize if your answer is correct. So the steps for solving are similar to the steps for solving an equation. We want to write the absolute value equation. We want to isolate it or get it alone on one side. And then if your absolute value bars are on the left, you can be sure, pretty much sure, that you have an and situation if it's a less than, and an or situation if it's greater than. Okay, and then we can always check some values. So let's get these steps done. I think I'm going to show you a little bit different as well. Write the absolute value without the bars, greater than or equal to 3. Write the absolute value without the bars, flip your inequality, and negate your number. So here I did a flip. Here I negated my number. And you'll see me do that a lot. So we're going to solve each of these. Okay, x is greater than or equal to 4. And x is less than or equal to 1. Now, is it an and or an or? We're going to make use of our number lines to help us. We're going to put down a 4 on the number line and a 1 on the number line. So we have 1 and 4. Now, this first inequality says our x's are greater than or equal to 4. So we're going to shade from 4 and go greater than. The second part says our x's are less than or equal to 1. So we're going to shade and go less. Well, this is a disjunctive or an or situation. I like to say, well, if you're standing on one of these, you can only be standing here, or, we're going to move this little guy, here, or. You have to jump over the river, here or here. So we're going to rewrite these two situations. Our x's are less than or equal to 1, or our x's are greater than or equal to 4. Let's take a look at another one. Let's get the absolute value bars alone. So to do that, I need to multiply both sides by 2, which will give me the absolute value of 4 minus 2y is greater than 8. I'm going to split it into two inequalities. 4 minus 2y is greater than 8. Keep it the same without the bars. Then on this side, we're going to flip and negate. So 4 minus 2y, flip your inequality, negate your number, or your whatever is on the right-hand side. Now we can solve. All right, we're going to divide by -2. When we divide by a negative, we flip our inequality. There's all sorts of flipping going on. 2. Flip your inequality. So let's take our two numbers, positive 6 and negative 2. Let's plop them on our number line. Let's shade the way they say. Y is less than negative 2. So open circle, less than goes to the left. Y is greater than 6. Open circle, greater to the right. And we have our little guy hopping over, so again, it's an or. He has to stand there or there. So just rewrite these. And I did not mean to put that equal to. We've opened circles this time because we don't also have an equal to. All right. So number 3, I'll do this quickly, and you can follow along. I want the bars alone. I have to divide by 7 as well. They're still not alone. And now we're going to split. On the left, keep it the same. On the right, flip, negate. Flip, negate. So we have two numbers to put down. This is the same as 1 2/3. So I'm going to put a 5/3 in and a 3. And it says my x's are less than 3. So that's shading to the left. And it says my x's are greater than 5/3. So it's shading to the right. So we actually got a conjunctive answer this time. So all of our x's are in the middle. They're in the middle of 5/3 and 3. And we have open circles, so less than on each of those. Now I mentioned earlier we could check. You could check a value here, and it should not work. You can check a value here, and it should not work. Maybe over here you'd check 0. Maybe over here you'd check 10. And then you'd want to check a number between 1 2/3 and 3. Maybe you'd check the number 2. And if you do a check and you check the number 2,